Hi. Today we discuss how to convert electrochemical cells into electrolytic cells. We know that in electrolytic cells, chemical energy is converted into electrical energy. Slowly, by applying external voltage, we can convert this into electrolytic energy, electrolytic cells. How? In the last video, I explained how to construct the electrochemical cell. Electrochemical cell by taking an example, Daniel cell. In the Daniel cell, we have two of cells. We have two of cells. In the Daniel cell, we have two of cells in which anode is a zinc rod, cathode is a copper rod. These two are connected with a copper wire externally, and internally with a salt bridge. Internally, two solutions are connected by a salt bridge. Internally, externally, words are important. These terms. This is the zinc rod, which acts as anode. This is the Daniel cell. Daniel cell. Common name is galvanic cell or voltaic cell. This is a specific cell constructed by scientists, so it is called a Daniel cell. In Daniel cell, anode is zinc rod, cathode is a copper rod. These two are dipped in their respective salt solutions. What is the salt solution of zinc? Zinc sulfate, which gives us Zn plus 2 ions and SO4 minus 2 ions. All this salt solution contains zinc plus 2 ions and sulfate ions. In this also we take copper sulfate. Copper produces Cu plus 2 ions and SO4 minus 2 ions in the solutions. So when these are connected internally and externally with the copper wire, a device is kept. Device means to identify the flow of current. Electrons flow from left to right, whereas current flow from right to left is the most important thing. The direction of the electrons and the direction of the current. These two are opposite in directions. Okay. In this, at a unit or unity concentration, electrode potential, this potential of this cell is 1.1 volts. EMF of the cell. Potential of the cell, EMF of the cell, electromotive force of the cell is equal to 1.1 volts at a unit concentration. All the Zn ions are in the unit concentration per liter, means concentration 1 molar concentration. At that condition, the electrode potential of the cell is equal to E naught of the cell is the 1.1 volts. E of the cell, it is E of the cell. Now, when external voltage is applied, when say all the off cells are same only, when external voltage is applied, how do you apply? Yes, like this. Here some resistance is there, and here we connect the resistance at this place. Yes, resistance is more. External means here battery is applied in the circuit. That is a second stage. First stage we don't apply. Okay, if you don't apply external voltage, what happens? Current flows from right to left, electrons flow from left to right. Whenever external voltage is applied, how external voltage is applied? Here copper rod only. Yes, here copper rod is there. Copper wire, not copper rod. Copper wire. Yes, these are respective rods: zinc rod, copper rod, and here there is a device to identify the flow of current. Now, when we apply external current, how do you apply? Please watch me carefully. Here we apply external This is the resistance. This is external voltage battery. Now a wire is connected to the yes at this position. For example, voltage here, resistance is more, current how much current was introduced into this electrolytic cell, less than 1.1 volts. For example, external voltage is equal to less than 1.1 means current same direction flows, means current flow from right to left only, electrons flow continuous same, electrons flow from left to right, no change in the direction of the either current or electrons, no change in the direction, because external voltage applied is less than 1.1 volts. External voltage is less than 1. That is external load, EXT, external voltage. Here the voltage of the cell, EMF of the cell. External voltage is less than 1.1, continues the same. This is electrolytic cell, electrochemical cell. This is also electrochemical cell only. No change in the current direction of the current or electrons. But whenever external voltage is equal to 1.1 volts, what happens? There is no any flow of current or flow of electrons. Stops flow of electrons, stops current also. No change in this device, whether it's galvanometer in the circuit, it shows vertical position, not left. Here left side current flows, left to right current flows. So direction of the arrow mark in the galvanometer is left to right. But here no left, no right. It is vertical. It means vertical position of the galvanometer shows that current does not flowing or electrons also not flowing. That is because external voltage 1.1 is equal to electromotive force of the cell. These two are equal. So no flow of current, no flow of electrons. But this is the common condition. First condition. Third condition, whenever external voltage is greater than 1.1 volts, external potential is greater than 1.1 volts. Now reverse to this means in the circuit electrons, external circuit copper wire, electrons flow from right to left electrons flow. Current flows from left to right, means reverse first condition. It means if it is electrolytic cell, this becomes electrolytic. This is electrochemical cell, this is electrolytic cell. Reverse it. So it means we are able to convert electrochemical cell into electrolytic cell. It means here anode is left side, cathode is right side. Here that anode becomes cathode, and cathode becomes anode. That changes take place, and reaction here spontaneous, here reaction will become non-spontaneous. I hope you have understood. This is how to convert electrochemical cell into electrolytic cell by applying external potential. Again I am telling in short, this anode reaction, oxidation reaction place, here oxidation reaction takes place opposite. Here in the normal condition, Daniel cell potential is 1.1 volts. Wherever external voltage applied less than 1.1, current continues the same direction only, left arrow mark here left side only. But whenever external potential is equal to 1.1 volts, now there is no any change in the direction of the galvanometer current device. It is only vertical direction, because no current flows, no electron flowing, no flow of electrons, no flow of current at this position. Whenever what is the condition for no flow of current and no flow of electrons? Whenever EMF of the cell is equal to EMF of the external voltage. If both are equal, no changes take place, the reaction stops, no flow of current, no flow of electrons. But whenever external potential greater than 1.1 volts, all will be reversed. Electrons flow will be reversed, current flow will be also reversed. It means electrochemical cell is converted into electrolytic cell. Thank you all.